today's lesson. Today I'll be talking to you about oxidation-reduction reaction. And here is a quick write-up on your screen. Oxidation-reduction reaction involves two opposing yet complementary processes. Every oxidation must be accompanied by a reduction, and every reduction must be accompanied by an oxidation. So, with this said, here are some awesome definitions I have about oxidation and reduction right here. For oxidation, to determine if a compound is oxidized or reduced, if it is oxidized, that is, if oxidation occurs, addition of hydrogen will be observed in the resulting compound, that is the product from the reactant. The other compound having the addition of oxygen is what is the oxidation. While for reduction, the removal of oxygen is reduction. And the second I have here is the removal of hydrogen. Don't worry, at the middle of this class I will give some awesome examples of oxidation and reduction. So removal of hydrogen is also oxidation. Also addition of hydrogen is reduction. And the next I have here is addition of an electronegative element, and for reduction is the removal of an electronegative element. Just think of oxidation as the inverse of reduction. That's just the inverse of reduction, or inverse of oxidation to be reduction. And the next I have here is removal of electropositive elements for oxidation. For reduction, it is the addition of an electropositive element. Okay, now here is how to determine oxidation and reduction. I'm going to give you some awesome examples. Just stick with me. Now, for when the condition is addition of oxygen, how to determine if a compound is oxidation process or reduction process. Let's say you have this chemical formula. You have carbon plus zinc oxide, which yields carbon dioxide. That is also can also be called carbon dioxide plus zinc. This equation is not balanced yet, so let's go ahead and balance the equation. This will have 2 here and right here. Okay, let me make this a bit spacious. Just a sec. View me. So this right here will be zinc oxide, but 2 molecules of zinc oxide. Okay, let's say for instance you have this chemical equation. You have to determine the oxidation and the reduction from this statement, which says addition of oxygen is what is oxidation. So to determine the oxidation of this chemical equation, just look at the one that has oxygen was added into, and that will map to this. Okay, why not use another pen? Sorry, let me use a green pen here. This is oxidation. If you notice, carbon was initially just 1 molecule of carbon here, attaching with no oxygen, but came to this other side to be carbon 4 oxide. That means oxygen has been added to it. So this part is what we call the oxidation. This is the oxidation. And reduction is removal of oxygen. As you can see, initially at this part, sorry, let me just change that pen. Initially at this part, it was 2 molecules of zinc oxide, and came down to this part to be just 2 molecules of zinc, having the oxygen removed. So this is automatically a reduction. This is reduction. This is reduction. this is considered as reduction. So the carbon to carbon 4 oxide is the oxidation, while the zinc oxide to the zinc is the reduction. That's that about that. The second I have here on my list is removal of hydrogen slash addition of hydrogen. Now, removal of hydrogen is the oxidation process, while addition of hydrogen is the reduction process. When hydrogen is added to a compound, that compound is reduced. When hydrogen is removed, the compound is oxidized. Are you getting the difference now? So oxidation and reduction. So why not give you some awesome example about removal and addition of hydrogen? Okay, let's take for instance you have this compound to be H2S. This should be, of course, this should be hydrogen sulfide plus chlorine gas, which on chemical reaction yields 2 molecules of hydrogen chloride gas plus sulfur. Okay, now just watch this now. Listen attentively to my explanation. Like I said, removal of hydrogen is actually an oxidation process, is oxidation. Removal of hydrogen is oxidation. Look at this process here. Initially this was hydrogen sulfide, isn't it? That's H2S. Hydrogen sulfide here. Hydrogen sulfide here move down to the product part to become, sorry, let me just erase this stuff. I'm gonna erase that. Okay, that's taken care of. To become just sulfur here. So in this case, this is what we call the oxidation. Why? Because hydrogen has been removed. This is oxidation. Hydrogen has been eliminated from the reactant down to the product. The product is now sulfur, no longer hydrogen sulfide. And if you take this other process, if you take a look at this other process here, you'll notice hydrogen has been added to the chlorine gas. Chlorine gas here was initially Cl2, denoting it's a chlorine gas without hydrogen, but came to this other side of the equation to become this. This became that. So this is the reduction process of this reaction. So this is reduction. So this is that about that. This is how to determine whether an equation is oxidized or reduced in a chemical reaction. So the next I have here is the addition of electronegative elements slash removal of electronegative elements. As I already told you, addition of electronegative elements is denoting oxidation, while the removal of the electronegative elements is denoting reduction. I also have some awesome example here of how you can determine whether an equation is oxidized or reduced. So let's take for instance you have 2 molecules of Na here, 2 molecules of Na. Of course, Na is called sodium in the solid state plus chlorine gas in gaseous state, which yields on chemical reaction sorry, yields 2 molecules of NaCl. NaCl, of course, NaCl is sodium chloride, our common salt, the edible salt we eat every day. So that is that about that. Now, to determine the oxidation process in this equation, note sodium here, initially Na here, was without chlorine. Don't forget, I said addition of electronegative element. Addition of electronegative element. Chlorine, which is an electronegative element, has been added to sodium at this other side of the equation to yield sodium chloride. So automatically this right here is the oxidation, and this at the bottom is the reduction. Why? Because electronegative element here, electronegative element is added to an electropositive element. So this also gives us the next on our list, which is what? Removal of electropositive elements and what? Addition of electropositive elements. So now chlorine here, electropositive element was added to chlorine to yield what? The reduction process. Reduction process. When electropositive element is added, it is reduction. When it is removed, it is oxidation. Just think of this case. Reverse this reaction. Take this one to be at the other side of the equation. Take this compound to be at the other side of the equation, which on decomposition would yield this other side of the equation. So now, which on decomposition automatically it will decompose, leaving out the electropositive element, hereby compelling this oxidation to still work as well. So guys, that's all I have for you for oxidation and reduction. I hope you liked this video. If you do leave a